Hello, so in this video we're looking at how to expand terms like this when there's a value here in front of the x. So basically in all the examples we've seen so far, inside the brackets it's just been 1 plus x to the power of n. And these ones are just a little bit easier to work with. But now we're looking at what happens when you have something in front of the x. So they're not massively different, to be fair. They're not too bad, but it does make a little bit of a difference when you plug things into the formula. And then you also have to rearrange a little bit when it comes to finding the range of x values that it's valid for. So let's give this a go. First of all, we identify our x and our n, like normal. When I say the x this time, though, I mean like it's minus 7x. So that's an important difference, minus 7x. And then our n is minus 5 over 3. So we've got those two. Now we can just substitute it in. So we start off with the 1. We have nx. So our n is minus 5/3. And then, if you remember, normally we would have just put an x here. But because we have minus 7x now, we need to put minus 7x. And this is where the brackets come in really handy. Because you put a bracket around each one, and yeah, you can multiply them when you expand it out. For the next one, we have the n, which is minus 5/3, times minus 8/3, because we're taking away 1. And we have 1 times 2, so just 2 on the bottom. But then instead of just x squared, it's the whole minus 7x that's being squared. Yeah, so again, that's really important. And for the next one, we have minus 5 over 3. Then we're going to have minus 8 over 3. Take away another one, we get minus 11 over 3. And this is all over 1 times 2 times 3, which is 6. And this time we get minus 7x cubed. Okay. So now we can just simplify all of that. And I'll just put this into the calculator. So it's 1 plus 35 over 3x. And then this is going to be plus as well. 980 over 9 x squared. Plus 7, oh, this is a big one, 75,460 over 81 x cubed. And you can, if you want to, I actually haven't been so far, but you can put like plus dot 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 to say that there are other terms, but we've only found these first few terms. And that's it. So we've now found the expansion and shown the first few terms. Now the other bit that's a bit different here is finding the range of values it's valid for. So just to remind you, this here was our expression. So far we put the x in a modulus, we say it's less than 1. So we do the same thing here, except our x this time is a minus 7x. We have that entire thing in a modulus, which is all less than 1. Now, of course, a modulus makes things positive, so we don't need to care about the negative sign. We can just say modulus of 7x is less than 1. And then we divide both sides by 7 to get the x by itself, so that the modulus of x is less than 1/7. And that's it. That's the range it's valid for. So as long as the modulus of x is smaller than 1/7, then this expansion, this thing that we found, is correct. And that's it. So hope that's made sense. If you have any questions or there's anything you weren't quite sure about, then let us know. And otherwise, I'll see you next time. Thanks.